Hi, I'm Jason, and I wanted to talk to you about a few items from your text this week. Let's talk about what a reactor scram really is. So, a reactor is a pressure vessel. Like when we learned about the fission barriers, one of the barriers is the reactor pressure vessel. And inside the pressure vessel is a support plate that holds all the fuel rods. In this area here is where the fuel is. We have control rods which have neutron absorbing material, such as hafnium and boron. Now, in a boiling water reactor, those control rods are inserted into the core from the bottom. But when we're operating at normal 100% power, most of those control rods are fully withdrawn from the core. And so they're down here. And they have tubes that allow us to hydraulically drive them in to the core to control reactor power. If we need to raise power, we withdraw them, and as we need to lower power, we insert them into the core. And then, of course, on a reactor scram, they insert fully into the core. And a reactor scram is one of our automatic protective features. Now, it's different than an isolation. So, while a scram takes care of the neutrons, right, the reactor, it puts the reactor in a safe shutdown condition, it doesn't take care of everything else going on. So we have pipes going into and out of the reactor pressure vessel. And these pipes, for flow in, for feed water in, for steam coming out, they have isolation valves. So in your text where it's talking about an isolation, we're talking about the automatic closure of these isolation valves that lock the energy in the reactor pressure vessel. So for both of these cases, the reactor scram and these isolations, we need some signal that tells the equipment, that tells the isolations and the reactor scram circuit, hey, it's time to do this. And that's where our logic comes into play. So we don't want the rods to go in or everything to suddenly isolate, without warning. We want it to be on a valid signal. If somebody bumps an instrument rack, we don't want that bumped instrument rack to cause a reactor scram or to cause the main steam isolation valves to close and cut off the steam, trip the turbine. We need to make sure that it's a valid signal. And I see in this discussion posts already, some of you are getting a little confused on what the logic means. Because we're looking for a valid signal, we want to use redundant instruments, redundant sensors. So I'm going to draw these sensors as contacts, like that. Now, if I have these two sensors powered by division alpha, by an alpha division circuit, power supply. I'm going to call this my alpha channel logic. And then that'll be my Bravo. Now in this logic, what we need it to do is we need to say, hey, when this gets a signal, when we get some logic, maybe we need one of the four, maybe we need two of the four, what combination of two of the four, if in order to send a signal to cause the isolation of the scram to happen. So that signal is sent via a relay. So this relay here, we'll call it alpha 1, and this one Bravo 1. The alpha 1 relay, actually we'll call it X-ray 1 relay and the Yankee 1 relay. They send a signal to make something happen. So let's say I have This is the circuit that actually causes the scram. And in order for the scram to happen, I need both of these to close. So right now, they're open. Okay? This is X-ray 1, which means this gets a signal from this relay. This is Yankee 1, which gets a signal from that relay. So let's talk about a 1 out of 2 twice. 1 out of 2 twice. The first part of that, the 1 out of 2, 2 out of 2, that's talking about the channel. So in channel alpha, 1 of 2, there's 2, I need 1 of these signals, which means if this closes, I now have power from here to the relay. And when I have power to this relay, X-ray 1 closes. So that's 1 of 2. Meets this logic to close that first relay. Now I don't get a scram yet, because guess what? This one is still open. I don't have electrical power going through here to the scram yet, because this is still open. This is still an open circuit, a Yankee 1. In order to get the scram, I need either the Charlie or the Delta sensor to get a signal. Now, in an ideal situation, whatever the signal these 4 sensors are monitoring, if it's a real signal, they should all 4 go, right? So they should all 4 close. But we're talking about the minimum needed to meet the logic. So let's say I get Charlie. Once the Charlie sensor says, hey, I meet this condition, now the Yankee 1 relay has power. And then it closes this relay, and then whammo bammo, rods go in, I get a scram. This is an example of an energized to actuate, which means these were de-energized or open, and I needed to energize them by closing them to line up power. You can do this, and this is where it gets a little confusing for some people. You can do this same 1 of 2 twice, right? This is the twice part. I need either Alpha or Bravo and Charlie or Delta, right? This is the twice part. 1 of 2 twice. I could also set this up as a de-energized to actuate. So in this setup, instead of parallel sensors, I've just put them in series. This is still a 1 out of 2 taken twice logic, but this is showing a de-energized to actuate. So I maintain power through here. This contact's closed and this contact's closed. The alpha contact and the Bravo contacts are both closed, keeping the X-ray 1 relay energized. This X-ray 1 relay energized is keeping the X-ray 1 contact closed. And then the same for the Yankee 1. Now, so 1 out of 2 taken twice, de-energized to actuate. In order to get the scram, I need to cut off power to this relay. If I open either one of these contacts, I still have power through the other one, which means I need to de-energize both of these contacts. So I have to cut off power to both X-ray 1 and Yankee 1. In order to cut off power to both of those relays, I need to open one of these 2 and one of those 2. So 1 of 2. Let's say Bravo opens up. X-ray 1 is now de-energized, and this contact opens. open, open, no power. No power, no power to this contact, but I still have power to the scram circuit, keeping the scram from happening. And then, if I also get delta, then the Yankee one is de-energized. And now I've cut off power to the scram relay. The scram relay de-energizes, and whatever valves it was keeping open or keeping closed, they open up and allow and they drive the control rods in. So that's a 1 of 2 taken twice, showing both energized to actuate and de-energized to actuate. Now a 2 of 2 taken once. It's the same idea, but instead of needing one in each of the 2 channels, I just need both in any one channel. So let's do an energized to actuate, 2 out of 2 once. So a 2 of 2 once. There's 2 in this logic channel and 2 in this logic channel. In order to energize this relay, I need both of those closed. So I get a signal on alpha and bravo that energizes this relay, which closes this contact, the X-ray 1 contact. I now have power to this relay for the scram or whatever, the actuation, the isolation for that circuit. And it's 2 of 2 taken once. I don't need both. One of 2 twice, 1 signal in each of 2 channels, 1 of 2 twice. Two of 2 once is 2 signals in any one channel.